polynomial functions and their zeros. Okay, our objective for this video lecture, identify the real zeros of a polynomial function and their multiplicity. Well, at some point we're going to need to define multiplicity because that's a new word for us. But let's get into a little bit about zeros of polynomial functions, and then we'll get into talking about the multiplicity of those zeros. Okay, what do we know? We know what a polynomial function is. A polynomial function is a function of the form f of x equals coefficient of the x to the n coefficient times x to the n term plus coefficient times the next term down plus coefficient times the next term down as you subtract 1 from the exponent plus coefficient times x plus constant. Okay, so here's an example. Example of a polynomial function, 2x to the fourth plus 6x minus 5. If you'd like, I could write this as 2x to the fourth plus 0x cubed plus 0x squared plus 6x, and I'll put a 1 there, minus 5, and again I could write that as x to the 0. So you can see, okay, the n in this case, this is a fourth degree polynomial, so there's your 4, 3, 2, 1, 0, and there's your coefficient, 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 and then constant or coefficient, which is a constant in that case. Okay, we're going to be solving polynomials in some future video lectures. What that means is, it means just like we did with solving quadratics, it means we're finding the roots or finding the zeros of the polynomial. Again, just like quadratics, because a quadratic is a polynomial. The zeros, or the roots, are those places where the function is equal to 0. Those places where the function crosses or touches the x-axis, the x-intercepts, are our zeros or our roots. So here's a polynomial. I just kind of drew a simple one. It goes up, comes down, goes up, touches, comes back down, and then goes up across and keeps going to positive infinity. Everywhere it crosses or touches is a zero or a root. Okay, in this case, this case, in this case, we're crossing the x-axis. In this case, we're touching the x-axis. And so those are your roots or your zeros. You do want to notice that in between your zeros, in between your roots, the function is either entirely above or entirely below the x-axis. So we come across here between this 0 and this 0. The function is above the x-axis. Between this 0 and this 0, the function is below the x-axis. And between this 0 and this 0, the function is also below the x-axis. Okay, as we did with quadratic functions, if a polynomial function is factored completely, okay, if we've written it as a product of expressions, okay, it is easy to locate the x-intercepts, to locate the roots, to locate the zeros by using the zero product property, by solving the equation f of x equals 0. Okay, so here's an example. This is a polynomial that's already been factored. Okay, so it's this factor times this factor. And if we look at this one, this is x minus 1, the quantity squared. If this factor is equal to 0, in other words, if x is equal to 1, doesn't matter what this one is, 0 times anything is 0. Or if this factor is equal to 0, in other words, if x equals negative 3, it doesn't matter what this factor is, 0 times anything is 0. And those are our solutions or our roots. Let's quickly take a look at this one. Okay, I move my paper up and they look at with my calculator. Let's just do a quick graph. I've already put it in here. Here it is. X minus 1, the quantity squared, times x plus 3. I think I graphed it using the standard window. And here's the graph of this polynomial. And you'll notice your zeros, it crosses or touches. at -3 and +1. If you want to go to second calc and you want to calculate the zeros, you just need to set your bounds. So I'll set bounds for the right 0, which is 1. Just go left side and right side of that 0 and then press enter. And you can see that it came up with a 0 of 1 right here, which we have here. We can do the same thing for this 0 over here, which is at x equals -3. Okay, let's continue. So we're going to define the word real zero. Okay, a real zero. If f is a function and r is a real zero for which f of r equals 0, then r is a real zero of the function. So just give it, what's a real zero? Something which you put it in results in 0 coming out of the function, results in you being on the x-axis. Okay, here's an important thing to kind of pull it all together. Given a function, the following 4, and I'll write the word 4 in here, the following 4 statements all say the same thing. R is a real zero of the function. Okay, that says the same thing as R is an x-intercept of the graph of the function. So a real zero is an x-intercept. An x-intercept is a real zero. X minus r is a factor of the function. So if r is an x-intercept, x minus r is a factor. If r is a real zero, x minus r is a factor. These all say the same thing. They're interchangeable. And finally, r is a real solution to the equation f of x equals 0. So we can interchange these 4 things as necessary. Let's take a look at that in our first example here. Find a polynomial of degree 3 whose zeros are -3, 2, and 5. Okay, so it says right up here, r is a real zero. That means that x minus r is a factor. Okay, so if r is a real zero, then x minus r is a factor. Okay, so we can say that x minus -3 is a factor. Again, x minus r is a factor, so x minus -3 is a factor. X minus 2 is a factor, and x minus 5 is a factor. These are 3 factors. Okay, those are factors. So, any polygon of the form f of x is equal to a, and I'll talk about the a in just a second. I'm going to write this as x plus 3, a times x plus 3 times x minus 2 times x minus 5. As long as a is not equal to 0, okay, qualifies. Okay, any polygon that has, if these are its 3 factors, any polygon in which these are, x minus r is a factor, and I'll talk about a in just a minute, qualifies as a polygon of degree 3 with these zeros. Now about this a, okay, let's talk about that a. This a, of course, we know from our transformations work, okay, this a, of course, stretches. Again, we know this from our transformations work, compresses, or reflects about the x-axis. I gotta spell reflects correctly. okay? None of which, again, as we've seen in previous video lectures, none of which affect the x-intercepts, okay? So we're not going to worry about, we'll make use of this later, but that A can be anything, but it doesn't change the fact that these are still your x-intercepts. Okay, so let's let A equal 1. Just to come up with one polynomial function, and the easiest one, that's of degree 3 with these 3 zeros. Okay, so letting A equals 1, f of x is going to simply equal, we'll let A equal 1, so we'll just have x plus 3 times x minus 2 times x minus 5, and I'm going to multiply these two terms first. This is x plus 3 times x squared, minus 5x minus 2x is minus 7x plus 10. And now I'm going to multiply these two, and I'm going to have to do this one out, and then I'll simplify it after that. So this is x cubed minus 7x squared plus 10x, that's the x being multiplied by all three, plus 3x squared minus 21x plus 30. Okay, now let's pull it all together. And the f of x is equal to, well, x cubed, there's only one cubed term. I have two x squared terms. They combine to give a negative 4x squared, or a minus 4x squared. I have two x terms, which combine to give a minus 11x, and I have one constant term plus 30. Okay, so this is my polynomial, and of course this is the one in standard form. Okay, this is the standard form. We saw that in a previous video lecture. This is now in standard form. The degrees descend, highest degree. It's a third degree polynomial, which is said right here. Find a polynomial of degree 3. Well, here it is. Okay, let's take a look at the graph. We know that these, negative 3, 2, and 5 should be zeros. So let's put this in the calculator. I'm going to put my calculator off to the side for a second and put it in there so I can see it, and then I'll put it on top. X cubed minus, whoops, made a mistake there, minus 4x squared minus 11x plus 30. Okay, so here I have my y equals x cubed minus 4x squared minus 11x plus 30. I'm going to graph it in the standard window, and oh, it looks like I need a bit more in the y direction. So I'll go back to my window. I'll make my y go from negative 20 to 20 just to see the entire graph, and I'll count by 5s. Why not? And oops, I still missed it. I'll do one more window change. I got to go a bit higher in the y direction. Let's go to 25 and see if I get it that way. And I should have gone to 30. Okay, let's go back and let's go to 30. And hopefully I get it. Well, I'll tell you what, close enough. We're concerned about the x-intercepts. We're concerned about the zeros. So there they are. There are 3. There's negative 3 right here. There's positive 2 right here, and there's positive 5 right here. And again, you could go to second calc and choose zeros, and then you could, I'm looking at the middle one, you could choose to the left and right side, and then ask the calculator, and it does indeed show you right here that this middle zero is 2. Okay. Now, let's talk about multiplicity. Okay, so sometimes a factor appears more than once. We call that multiplicity. Okay, so multiplicity how often a certain root, a certain zero, is part of the factoring. Okay, so let's take a look at example 2. For the following factored polynomial function, identify the zeros and their multiplicity. Well, I'm going to write this out and expand it and make it look a little bit more obvious as to what we're looking at here. So I'm going to write this as f of x equals 2. And I'm going to write this as x minus 0. Whoops. Yes. And then I'll write this one as x plus 2. And then I'll write this one as x minus 4 to the 4th. So you can see here that 0 is a factor. If this equals 0, if x equals 0, this factor is 0. It doesn't matter what this one, or the 2 is, because 0 times anything is 0. If this factor is negative 2, then if this x is negative 2, then this factor is 0. Again, 0 times whatever this is, times whatever this is, times 2 is 0. And lastly, for this factor, x minus 4 to the 4th, if x is 4, then 0 times whatever times 2 is going to be 0. Let's expand this. Okay, this is saying 2 times, I want 2x minus zeros, because I have it twice. I want 1x plus 2, and I want 4 x minus 4s. Okay, so that's totally expanded. Okay, so how do we, now we look at this and we say, okay, 0, the number 0 from right here, 0 is a 0 or a root. Okay. It happens twice. Okay, so with multiplicity of 2. Okay, because the exponent is a 2. Note the exponent of 2. Okay, but I wrote it out, I expanded it. But you can look right here and say the exponent squared. I have 2 of these zeros. Okay, how many times is negative 2 a 0 or a root? Negative 2 is also a 0 or a root, but its multiplicity is 1. Again, note there's a 1 right here. We just don't write it. It's x plus 2 to the first power. Okay, again, note the exponent, or in this case, the lack of exponent, but the lack of exponent meaning it's an exponent of 1. And finally, 4, right here, 4 is a 0. 4 is a 0 or a root, but it has multiplicity 4. Multiplicity, how often a certain 0 is part of the factoring. It's part of the factoring 4 times. Again, note exponent of 4. Okay? So that gives you a sense. You can begin to pull in some multiplicity, what's going on there with multiplicity and what that means. Now I want to pull out a couple of, well, first of all, let's take a look at the graph. And I think in this one, yes, let's take a look at the graph. Then I want to come in and pull some other things with this. Okay, so the graph of this one, I think I got it right here. F of x equals 2x squared. Okay, so y equals, let me turn my calculator back on, clear this one. Y equals 2x squared, parenthesis x plus 2, parenthesis x minus 4 to the 4th. Okay, now I've already done this and worked with this, and so you need to have kind of a specific window settings to see it. The window settings are a little bit more complicated. We're going to go x from -5 to 10, and we'll count by 1. And the y, I'm going to go from -500 up to 2200, and I'm going to count by 500ths. I prepared this problem, and this is going to make it work for us. And here it is. Okay? So as you can see, here's the root -2, here's the root 0, and here's the root 4. Okay, I want to notice a couple things here. Notice that with the multiplicity of 1, the root of -2, the graph crosses the x-axis at that root. Notice at the root of 0 and the root of 4, which are both, here's 0, here's 4, they both have even multiplicity. One has multiplicity of 2 and one has 4. Note that I call that bounces, but it touches. It touches but doesn't cross the x-axis. I kind of speak to you have a bounce there. Okay, so we're going to see this in a minute in the fact that an odd multiplicity crosses the x-axis, an even multiplicity touches or bounces off the x-axis, does not cross. Okay, the last thing I want to pull up with this example is, notice here if we add up our exponents, or if we add up the multiplicities, notice if we add multiplicities, okay, which are the same thing as adding the exponents, okay, same as exponents, if you add the exponents, okay, you determine the degree of the polynomial. Okay, so this polynomial, f of x equals 2x squared times x plus 2 times x minus 4 to the 4th is a 7th degree polynomial. 1, 2, 3, 4, 5, 6, 7. We're going to have x to the 7th power once we've multiplied all of that out. So a couple things we're going to see pop up here in the next example, as well as in future video lectures. Multiplicities, adding the multiplicities or adding up the exponents, and again, don't forget there's a 1 here. Tells you the degree of the polynomial. Okay, so this is a 7th degree polynomial, and it also talks about if your multiplicity is 2, you get a bounce, you get a touching of the x-axis. It's a root that touches but doesn't cross. If your multiplicity is odd, like 1, it'll cross the x-axis. Okay, final example. Okay, let's take a look at example 3 here, and let's talk about, let's kind of pull this all together a bit with the zeros and multiplicities. So we have a factored polynomial, x plus 1, the quantity squared, times x minus 2. Again, factored polynomial. What are the x and y intercepts? Well, the y-intercept is the easiest, right? Okay, so y-intercept means x equals 0. Not bad. Okay, so we f of x, we put 0 in for x. 0 plus 1 squared times 0 minus 2. Well, that's 1 times -2. And how about the y-intercept is -2? Okay, what's the x-intercept? That's when y or f of x equals 0. Okay, so we say x plus 1, the quantity squared, times x minus 2 equals 0. It's already factored, so we know that either x plus 1 squared equals 0 or x minus 2 equals 0. Well, this one is x is equal to -1 and x is equal to +2. Okay, let's graph it. Okay, so we're going to go into here, and we're going to go to y equals. We're going to clear this one out, parenthesis, x plus 1, the quantity squared. Where's my squared key? Good. Parenthesis, x minus 2. I think my window's off, so I'm going to go back to my standard window. And let's see if I do. Oh, I did pretty well. Okay, so there it is. Okay. We can see that it crosses the x-axis at -2, which we see right here. It should cross at -2, and it indeed does. If you want to, second calc value, when x is 0, what's y? Y is -2. And you can see that our zeros are -1 and +2. Okay, let's go back in here. You can see that here's -1, here's +2. Again, if you want to calc your zeros, just use your left and right, set your bounds, and then have the calculator find it for you. Whoops, oh, I mismade this. Let's see. Let's quit this. Go back to the graph, second calc, my 0. Oh, it's not noting this one. Nope, that's a max. It's not a 0. Okay. Ha! So it's not, you have to do that one as a maximum. I wasn't aware of that with the calculator. So let's look at that one as a maximum. So here we have, anyway, so when -1 and +2 are our zeros, our roots, okay. Okay, let's see here, letter B. For each x-intercept, determine multiplicity. Multiplicity. Okay, well, x minus 1, okay, so x minus 1, x plus 1 squared, okay, expands to x plus 1 times x plus 1. So the root x minus x equals -1 is of multiplicity 2. Okay, so that root has multiplicity 2. And again, it's the same thing as the exponent right here. Okay, it has an even multiplicity of 2. X minus 2, okay, x minus 2 is just its own, so x equals 2 only takes place one time, is of multiplicity 1. So x minus 1 happens twice, x minus 2 takes place, the root x negative 1 takes place twice. It's a multiplicity 2 root. The root x equals 2 is a multiplicity 1 root. And this will bring us to the last piece of this video lecture. Okay, multiplicity. Okay. If a root is of even multiplicity, okay, even multiplicity, okay, the graph touches the x-axis, touches the x-axis, okay, the graph touches the x-axis. It does not cross, what I was saying first, it does not cross, and I say it bounces. It bounces off of the x-axis. Okay? And if a root is of odd multiplicity, the graph crosses the x-axis at the value of the root, of course. So a lot here. We'll do some more as we look at these graphs. But there's your zeros and a bit of multiplicity. And as I say, we'll get more into this in our next video lecture and our next couple of video lectures.